Welcome to video number one of topic 5.8. I'm going to combine 5.8 and 5.9 into one cluster because it takes what we've learned about the first and the second derivative and their relationship to the graphs of a function, and it asks us to make connections between the graphs of the original function and the first derivative function and the second derivative function, right? And so our part one here is going to be, if we're given a function f of x or g of x or h of x, whatever the name is, doesn't matter. If we're given an original function, can we create the graph of the derivative function? Okay, so let's think about how we're going to approach this. So if we're given the graph of any function, we got to remember that whenever we take the derivative at a specific point, we're actually looking for the slope of the tangent line. Let me change colors here. This means that we're looking for the slope of the tangent line of that function at that x value. We're calling it that x value c. So if that's the case, then when we look at the slopes of the graph of f, so if we're given the original graph of f, the graph of the original function f, the slopes of that graph are going to become the y values, and I'm going to use a different color here, the y values or the function values of the graph of f prime. If f prime is the function that finds the slopes at different x coordinates, then the graph of f prime represents the slopes of the original graph of f. So I'm going to use this as our first example here to plot some points and see if we can find the slopes at a specific x value. So we're going to start with x equals -2. So at x equals -2, that would be the y coordinate, that would be the f value, right? F of -2 would be 1. But f prime of 2 would be the slope of this graph at x equals -2. Well, the slope of this line segment is 2 because I go 2 up and 1 over. So f prime of -2 would be 2 because this is the slope of f at x equals -2. So in a little bit, we're going to create a graph for f prime that's going to include the slopes of f as the y values on my new graph. So I'm going to go to the next one. Let's find f prime of 1. F prime of 1. F prime of 1, well, this is the f function value, but f prime would be the slope at this point, but the slope at this point is the slope of the segment, and that's going to go down 1 over 3. So then this would be -1/3. F prime of 3. F prime of 3, that would be at this point. This blue point is the function value. So f of 3 is 2, but I want f prime of 3, that's the slope of this line segment, and that would be 0. And then f of 6, I'm sorry, f prime of 5, let's do that one first. We'll do them in order. At f of 5, what's the slope at this blue point? Well, that's going to be -1. And then f prime of 6, well, that would be the slope at this point, and that's also -1. Okay, so everything that I've highlighted in blue here are the function values. But now let's go back and let's do these values. And I'm going to change the color here so that we can maybe get a better understanding. If I change the color, so f prime of -2, we said was +2. So when x equals -2, the slope should be right here. So the point in blue is the point on the original function f. The point in green is going to be a point on the derivative graph. And we're saying that these answers are the slopes. So therefore, when x equals 1, my y value is going to be the slope of this original graph, which would be about right here. F prime of 3 is going to be 0, so that's going to be here. F prime of 5 is going to be negative 1. Let me go back. I don't need to highlight. F prime is going to be negative 1. So F prime of 5 is going to be negative 1. And then F prime at 6 is going to also be negative 1. So that's going to be there. So notice I'm going to create a new, and I'm not going to finish this in example 1, but we're going to finish this in subsequent examples. We're going to create, connect the dots here, and create the derivative graph based off of the slopes of the original graph. So wherever you see a blue point, that's f of the x value. Wherever you see a green point, that's the slope of the f graph, and I'm going to create a new graph where the y value here is the slope on this graph. So let me go back to this box because this is going to be the key to what we're doing. The slopes of the original function are going to become the y values on the graph that we're going to create for f prime. Can we try that again? So let's try that again with example 2, and then we'll pause here. This is the original graph of g of x. Plot the points on the graph of g prime where x equals negative 3, x equals negative 1, 0, 2, and 5. So I'm going to create a table this time to maybe organize my information a little bit better. So they're asking me at x equals negative 3, negative 1, 0, 2, and 5. And I'm actually going to create a g column, but then I'm going to create a g prime column. And I'm doing them different colors so that you can see the different things I'm looking at. So when x equals negative 3, this is the point. The point is 5, right? The y coordinate, the function value, g of negative 3 is 5. But now g prime is asking for the slope. What is the slope at this point? And so if you look and follow rise over run, this would be 1 down, 1 over, 1 down, 1 over, 1 down, 1 over. So my slope is negative 1. And so what we're going to do is we're going to plot that point. At negative 3, I'm going to plot negative 1. This value represents the slope at the blue point. And then we're going to go on. All right, so let's find g of negative 1. G of negative 1 would be the y coordinate of that point. So that's 3. But g prime of negative 1 would be the slope at negative 1 of this function. Well, the slope is still down 1 over 1, down 1 over 1, down 1 over 1. So I'm going to plot the point at negative 1 because this is still negative 1. And after a while, you realize, oh, so x equals 0, my y is 2, but my slope, I'm going down 1 over 1, down 1 over 1, is still negative 1. Well, my slope is going to be the same throughout because the slope of this graph is always the same value because it's the same slope because it's a line. So my blue column is going to change, right? At x equals 2, that would be 0. At x equals 5, this would be negative 3. But g prime will remain negative 1 at 0, negative 1 at x equals 2, negative 1 at 5. And so we have the plotted points of g prime at those specific values. And so if I have to make the sketch, I now realize that this is a constant function because my slopes never change because the slope of this graph is always the same. This would be the graph of g prime.